All right. Awesome. Oh my God. This has been a close call. Oops. Yeah. This has been a close call. Oh my God. Oh. I'm sorry. I'm a little late. I'm a little all over the place. Yeah, my code stopped working and I had to try and fix everything and it just took way too much time. Recording reminder, I have started the recording this time. Wait, have I? Hold on, I have. Come on, have some faith in me, buddy. Have some faith in me. I always start the recording. What do you think? Oh my God, oh my God. Sweet. I know last time I kind of screwed it up. I keep screwing it up every time. But I've started recording this time. I even did like a little test run, a little trial run to make sure that the recording indeed works. Okay. Just give me a second, guys. Give me a hi in the chat till then. Hey guys. Give me a quick hi. And I will set things up. Hey Prashant, what's up? How you doing? I know you've been kind of excited for this one, haven't you? You've been a little excited for this one. Yeah. Yeah, it's going to be very scuffed. It's going to be really scuffed. This entire thing. I have no idea how it's going to go. So I'm a little concerned. I'm slightly concerned. Oh boy. But I think what we want to talk about is really interesting. So as long as we're able to follow along with what the hell is going on, I think that's more important than the demos working, right? Right? Please give me a 1 if that's true. It's fine if the demos are scuffed, right? Please, guys, come on, go easy on me. Give me a 1 in chat if it's fine, if it's a little scuffed today. Okay. I just need some water. Oh, actually, you know what? Give me some time. Let me get some water. Let me get some water. All right. Huh. Oh, hey, Alka. How you doing? Always so good to see you. Oh, Asha is here as well. That's amazing. Oh, Asha, you excited for this as well? That's cool. I'm just reading the chats in like such a weird order at this point. Waiting for some rag and to see why Pydantic AI matters. This isn't going to be a huge one on Pydantic itself. We're going to focus more on RAG, or rather agentic RAG, but we will be using Pydantic as our agentic framework. I mean, whenever there's like a new agentic framework which comes out and people show a lot of interest in, I try to build as many use cases as I can with it. So I'm just trying to stick with Pydantic just to build some stuff with it and see how it pans out for me. Well, some opinions have changed since I've been using Pydantic. Some opinions have definitely changed. Yeah, I mean, we talk about it. We'll talk about it. Yeah. Before we start, audio good? Just give me a 1 in chat if you can hear me all right, or if the music is all right. I mean both. If the music and my voice is all right and it's not super disturbing, give me a 1. Give me a 1 in chat, guys. Give me a 1. Okay. All right. I like that. Thanks. So, you know what? I think it is time to get started. Oh my God, I don't even have an intro planned out. Okay. One note to anybody who's planning to stream or, trying to make content. Don't try to build your demos at the last second, okay? because you're gonna definitely get some C++ error and you won't be able to install any library and nothing will happen, and then you'll have to try to fix everything in the last second. Bad idea. Okay, always prepare 2 days in advance. Okay, enough jokes. So at this point, I think we all know why we're here, right? We're here for taking our RAG applications to the next level, and that's by using something called Agentic RAG. But before we start, I think all of us know what RAG is, right? Give me a 1 in chat again if you know what RAG is. Like at least the basic idea of RAG, and maybe build something with RAG. Give me a 1 in chat again. I know it's going to be a lot of ones in chats. Let's do it. Let's make YouTube think this stream is worth it. Okay, I have one. Anybody else? We've used RAG. Give me a 2 if you haven't used RAG, because it's important for me to know that whether I need to, like, how deep do I need to go, or should I even start by describing what RAG is? We don't need to do that, right? We can skip it. I think we can skip it. Fair enough. Cool. We're skipping it. Yeah, everybody has a 1. Okay, cool. So, but if you did not know what RAG was, or just need like a quick recap, we did make a video on this just a couple of weeks back. Actually, in fact, RAG was our first stream. So we have the video for that. I would definitely suggest you check out that video, because it's a stream dedicated to just getting introduced to RAG, right? So it could be really helpful for you. Okay, I see 1, 2. That's fine. Okay, we won't get deep into RAG because most of us already know it, but let's just touch base on it. Okay, so don't worry about it too much. I will give you a demo so that you know what the hell is going on. Sweet. Hold on. Give me a second. Okay, sweet. Yeah, let's start with a little demo of what RAG is, right? Not exactly a demo. Actually, calling it a demo would not be fair. Let's share the screen. Work YTB codes. Unfortunately, I wasn't able to push this code. In fact, this code is not even committed at this point. It's not even done. Forget committing. So I will commit and push this code on our, on the same GitHub repo we've been using for ages at this point. And actually, you know what? I think I have it somewhere. Yeah. Oops. Come on. Open up. Yeah. This repo, we started off a little while ago. We've got 60 stars already. That's amazing. Thank you so much for sharing and loving this. This is great. Thank you so much. But okay, yeah, I will push all the code on to this repo once I'm done. I just need to patch certain things up, just a little bit here and there, and then you'll have the code available. Okay, so let's start with what RAG is. Essentially, whenever we are working with AI, we need a mechanism to provide AI with our own information, right? Sometimes AI would not have the answers to the question we need to ask, just because it's not trained on that data, or that data is so diluted that it's just so diluted that it doesn't come up in your queries. So let's start with some important questions which we need answers to. So the one I could come up, and the one I think some of you are already familiar with, is what a Pikachu's electric type moves. Yep, we're going to Pokemon again. Oh, the font is too small. Is it better now? I hope this is better. Okay, yeah. So let's start. So like I was saying, sometimes AI might not have the required information to answer the questions that you have, right? It could be because I don't know. Let's say the training, it's your data is there in its training data, but it's just too diluted, or it just doesn't have the data. Maybe it's proprietary. Maybe it's something critical to your business or very specific to your use case, and the model just doesn't have the data with it. In that case, you need to supplement that information somehow, and RAG is one of the ways you can do that. You know what? I just realized something. Yeah, the TV was not center aligned. Priorities, my friend, priorities. Oh my God, sorry. Yeah. So essentially what you do is, let's say we have an important question, right? What are Pikachu's electric type moves? Okay. I think I should make it a little bit more bigger. Cool. So what are Pikachu's electric type moves? Okay. Now let's assume the model has no information of who the hell Pikachu is. How dare it, by the way. So we need to provide it that information ourselves in the prompt. Okay. So whenever we're talking to the model, what we need to do is first create something known as the context. And that's what I'm doing here. So we start with the context, right? We say that, hey, I want to perform some vector search. And then I want to build a context object from that results. So we're basically going to a database and trying to get that information out. Then we prompt the model, but instead of just giving the user's query directly, like instead of taking this question and just giving it to the model directly, we are gonna pass our context object alongside of the query, right? And then we're gonna prompt the model accordingly. So hey, carefully study the following context to answer the user's question. So now the model will not just have the model will not just have the question, but also the potential answer in the same prompt. So instead of relying on the model's memory, we're now trying to make the model reason and get the answer, right? So it's our responsibility to make sure we build a context which can give us the right answers. So let's take it for a spin, shall we? Let's take it for a spin. I think I need to make this bigger as well. I hope this is big enough. This should be big enough, right? I think this is plenty big. Cool. So let's run this. Oh, nope. Yeah. So let's run this. So like I said, the first step is always to populate the context, right? So we are going to the vector database and we are going to populate the context and we are going to find the answer, right? And then the model will give us the perfect answer. So it gives us that, okay, Pikachu has 4 electric attacks: Thunder Shock, Thunder Wave, Thunderbolt, Thunder. It also gives us the levels at which it learns it, which is pretty cool. And then it can even give us some extra answer, whatever it is. Basically, this is an answer grounded in real information now. All right. That's essentially what RAG was. I know that's a terrible introduction to RAG. Watch that video. I've done a way better job there. But there are some problems with RAG. There are definitely a lot of limitations when it comes to RAG. Okay. The most important limitation which I want to talk about is in a form of an answer, in a question. So right now actually, you know what? Let's take a step back. For those who already know what RAG is, I believe it's most of you. I'm using LanceDB as my vector database, right? So what I've done is I've already gone ahead and taken all my data. It's the same data we used in the last stream. It's like Pokemon. So we're building all that data set. Hold on. The data is in this directory. And we have data which is basically markdown. We have the data in the markdown format for every Pokemon that we have, right? So this would include the kind of moves they learn, at what level do they learn it, and all those kind of fancy things. Actually, it would be a better idea if I just show you the data set right here. Yeah, this is the data set. Okay, it's this page but in markdown format. Okay, and I've gone ahead and gotten the data for some of the Pokemons which I really like. So, we have the data right here. And I've already written like a mini ingestion pipeline. What it does is it reads that data. It splits it up into smaller chunks. We're just using a simple chunking strategy here, like the recursive text splitter. And then, we split it up. We create embeddings from it. And then we dump it all into LanceDB, which is an amazing vector database, right? So we dump it all in LanceDB, but we also create a full text search index. So we are not just storing data in the vector form, we are also storing it as a full text search index. Are you guys with me? Can you please enable CC so we can view auto-generate captions? Can I do it on a live stream? Like, are we allowed to generate captions in a live stream? I mean, I have enabled it. That's chapters, comments. Dude, I have no idea how to enable captions in a live stream. I don't see an option here. The other streamers which do it, they probably have some kind of a real-time transcription service they're using, and then they inject it. But maybe for next time, that's some feedback I can take home. But you guys with me till here? The ingestion part, right? We just have some information, and we are dumping it into a vector database, and we are also creating a full text search index. For those of you who don't know what full text search is, we had discussed it in our last stream. Essentially, what a full text search index does is it stores data in the form of keywords. So it's better for like keyword based searches, or rather phrases. It's easier to search information when you have given phrases, right? It's kind of like the like operator in SQL databases, if you've ever used that, but a little bit more optimized for phrases rather than just individual words and things like that, right? So LanceDB. Oh, what LanceDB is? My bad. LanceDB is an embedded vector database. So when I say embedded, what I essentially mean is it's a database which runs in process. So if you have a Python app, LanceDB is running within your Python app. It's embedded, right? Which is cool. I'm really into embedded databases these days. But if you do not, but the beauty of LanceDB is that it just doesn't store data on disk. It can store data in an S3 bucket. So you can have huge data sources dump into LanceDB, and it can scale it really well because it's using S3, which is one of the most scalable storage solutions out there as its data layer. So it's a very scalable embedded database. And it uses something known as Lance, which is very similar to Arrow as its, as its storage format. Let's not get into all of that. It's an embedded database, which is pretty cool. We are using LanceDB as a vector database, and we are also going to be using LanceDB as a full text search engine. So like I said, I already have a simple ingestion pipeline, which dumps all the data in. So I've already created the embeddings. I've dumped it in LanceDB, and we're just going to use it from there. Okay. So we saw our basic RAG demo, right? It gave us the right answer. But what would happen if we change the question and make it a little bit more complicated? Like, just take it up a notch. So instead of just asking, hey, what is Pikachu's electric type moves? What if we ask it a question like, between Pikachu and Charizard, who has a more powerful normal type attack? Okay. So between Pikachu and Charizard, who has a more powerful normal type attack? Okay. Let's try to run this and let's just see what happens. Oh my god. I mean, I'm not even sure if it's gonna give us any coherent answer, but but I'm kind of curious. I'm kind of curious to see how it works. But while that runs, the biggest problem we're gonna have here is if you're doing vector search, right? And in my basic RAG, I'm doing a vector search, right? Vector search works on the semantic meaning of your chunks. So it's trying to see what chunks are kind of related to your input query. The problem in this query is there's a lot of meaning packed into one small sentence. We're talking about Pikachu's normal type attacks, we're talking about Charizard's normal type of attack, and we are comparing the result of Pikachu's information and Charizard information and try to get like a consolidated answer out of this. So the point I'm trying to make is it is a little tricky. It is a little tricky to optimize RAG pipelines to get answers for such use cases. Because if you look back now, oh my God, the model just went completely crazy. Hold on. I think the model went berserk over here. Yeah, it's going to be scuffed throughout. It's going to be really scuffed. But yeah, there you go. So based on the information provided, Charizard can learn various normal type attacks. So Charizard can learn these 2 attacks. But wait, what? It's not even talking about Pikachu. I mean, it's difficult to answer these questions in one shot, right? And the point is that even though you make your RAG pipeline better, you'll reach a point where optimizing your RAG pipeline further is just not possible, right? Optimizing your RAG pipeline further is just not possible. And the reason for that is that at some point you hit the law of diminishing returns, right? You need to adopt a mindset which goes beyond the traditional RAG that we have in order to fully give us a good answer. Make sense? The point is, RAG will start failing us. Eventually, RAG will definitely start failing us, and it just won't work. Okay, it just will not work. Are you guys with me? I know this is not a great start, but do you understand the problem we're trying to solve here? Like the limitations of RAG pipelines. Does it make sense? Give me a 1. Give me a 1 in chat. Okay. So like I was saying, we'll eventually with traditional RAG, we eventually reach a point where we can no longer improve the performance of our retrieval pipeline. It just doesn't work, right? I mean, we can technically keep making it better, but like I said, eventually the law of diminishing returns just kicks in. So it's not worth the effort. It's not worth trying to make your traditional RAG pipelines better and better and trying to improve the quality, right? So we really need to go beyond the mindset of a typical RAG pipeline, and we need to start thinking in terms of workflows. So what do I mean by that? What do I mean by workflows? Let's head over to Excalibur. You know what? I'm going to keep this open. Okay. So in a traditional RAG pipeline, this is what we were doing, essentially. We started with a user's question. So we had a query, right? We started with a user's query. And what happened was we had some kind of a retrieval logic. That retrieval logic was nothing but a vector search, right? So we were essentially relying on a vector database to populate the context. So we get the query. From the query, we generate an embedding. We give the embedding to the vector database. The vector database will give us back, let's call it the vector database. Yeah, the vector database will give us back the relevant chunks, which are similar to the query. And then we essentially give it to our model. So we give it back to our LLM. Right? The bottleneck in this pipeline, what we saw was that this process kind of failed us. This is where we got stuck, guys. This is where we got stuck. This process failed us. Because once you start getting into questions which are like more comparative in nature, or they're multi-part questions, right? There is no way for vector search to be able to answer that. Forget vector search. Even full text search cannot answer that. It's just not possible. It's not going to work, right? It's just not going to work. So what we need to do instead is try to break out of this RAG system. So how can we do that? How can we do that? So just keep this in mind and let's try to build a solution. Let's forget about RAG. Let's forget about agents. Let's forget about everything. And let's just think about how can we solve this problem? How can we solve the problem of comparing Pikachu and Charizard? How can we do that, right? So let's write down the question first. The question is, who is better? Who is better? Charizard, or Pikachu? And this time, oops. This time I remember how to spell Pikachu. I have done my homework. Okay, so this is our question. Who's better, Charizard or Pikachu? How do we find the answer to that? As a human, as a developer, right? As a human or as Python devs are not human. Don't take that out of context. But as a human, I would essentially go to this website and first go to Pikachu and see what are the normal type attacks it learns. So it seems like Slam is the best one it's got. Sweet. Then I will go over to Charizard and try to figure out what's the best attack it learns, which I guess is Rage. Or maybe Ember. No, Ember is not normal. So I think it's Rage. Yeah, Rage. 20, whatever. So I did 2 lookups. What did I do here? I did 2 lookups. Once I looked up information for Pikachu, and then I looked up information for Charizard, right? So what did I do? I went ahead and said, look up info for Pikachu and then look up info for Charizard right? And then based on the result I got from these guys, I made a deduction. Or I finalized, I got the final answer. Basically, what's the technical word for it? Deduction is right? We can call this deduction. I think we can call this deduction. I'm going to call this deduction. So I deduced the right answer. Correct? However, there is one underlying step which we did before this. My brain silently or just subconsciously made a plan. It kind of made a plan. So I first made a plan that, okay, I need to look up information for Pikachu and Charizard, right? So I first decided that, okay, I need to look up I need to answer 2 questions. And then once I've answered those 2 questions, I can use that information to find the right answer, which is Pikachu technically has the better normal type attack because Charizard only had Rage, which is 20. But if you look at Pikachu, Pikachu goes up till 80, right? So Pikachu should win this. Question. Cool. Now this is what we need to do. This is the answer, right? This is the answer this is the way you can solve questions like these, right? So we technically had some kind of a plan being generated. We kind of did some kind of planning. And then based on the planning, we did 2 retrievals. So each one of these are technically the RAG pipeline. So this is like invocation of one instance of the RAG pipeline. So you basically use your RAG pipeline to get the answer for Pikachu. And then you use the RAG pipeline to get the answer for Charizard. And then you took the answer for both of these questions, and then you gave it to a third party to deduce the right answer. So technically speaking, this is a workflow. This is not exactly a RAG pipeline. This is a workflow which uses RAG under the hood to get the right answer. Are you guys with me? Give me a 1 in chat. Give me a 1 in chat if you guys are with me, if you know what I'm talking about, if it makes sense. A quick 1 in chat. A quick 1 in chat. Oh boy. I just realized that I wasn't getting any messages, and thousands of messages just came in. I'm gonna say 1,000. Mr. Editor, make sure that you use the word thousands. When this video goes out, I want people to think there were thousands of messages in the chat, okay? And don't include this part. Cool. Okay, wait. Hold on. Guys, I'll have to go through all the questions again. No. This is good. This is good. We're talking about UV. Great. Wow. Oh my God. Chat is just crazy. But yeah, I'm using UV. I've become a devout user of UV at this point. Benefit of using UV. Great. At this point, I feel, Prashant, you are doing like a parallel stream in my chat. People have just started asking you questions. I'm sorry about it. I wasn't getting the chats. Now I just refreshed it and I've started getting it. But yeah, we had a stream on UV as well. Watch that video. In fact, Prashant was a guest in that video. So he's like the expert when it comes to UV. Great. Very common problem. Sounds good. Don't know shit about Pokemon. What makes one Pokemon better or worse? Hey, come on. Actually, you know what? I'm not going to comment on that. I think I'm going to be put into a lot of fire if I try to answer that. But okay, sorry, my bad. I just got really distracted. Glad to see people are still alive and active with me. Cool. So this is what we want to do. We want to build a workflow. All right. Now there are a couple of things to note. To technically note in this workflow. Okay, we need to note a couple of things in this workflow. The first one is we had some kind of a planning step. Okay, and that plan essentially decomposed or split the main question into smaller sets of questions. At this point, this happens to be 2 questions. It just happens to be 2 questions. It could be 3, it could be 4, it could be more. The point that we need to decompose the user's question into smaller questions. That's what we ended up doing here, right? We did some kind of decomposition, right? So important thing to know. Another thing which we also did is, remember I said I have I've got like a vector database and a full text search database. So I've got like 2 different indexes. Now, which one to use for which query? Which one to use for which query needs to be decided as well. Like for this, is vector search going to be a better option, or is full text search going to be a better option? So we need to make sure that we route the right query or the right sub question to the right retrieval strategy. Because remember one thing, guys, there is no generic or global retrieval strategy. Okay, there is no way on the planet that one retrieval strategy will answer all the questions out there. If anyone comes up to you and promises that, hey, I have a RAG solution which can take your data and answer any kind of questions, run away. Maybe take a picture of that guy before you run and send it to me, and then we can add them in Santa's naughty list. Okay, but that's the point. There's no one retrieval strategy which will give you all the answers. So we're going to have specialized pipelines, right? Like I said, one pipeline which uses vector search, one pipeline which uses FTS. Again, this is very nuanced. This is a very naive example. You could technically have one pipeline which does vector and full text search together. I mean, there are multiple different ways to do it. But the point is, eventually you run into different kind of retrieval pipelines, and you might want to route the query to the right pipeline. So there's some kind of routing happening under the hood as well. The point is, there's a lot of reasoning which is happening. Right? Yeah, so there's a lot of reasoning which is happening. And whenever we talk about reasoning and decision making in workflows, that's where we introduce agents. Okay, that's where we introduce agents. Okay, Prashant has a question. What makes one Pokemon better over the other? You know what? Let me make this question a little bit more precise. Because this is a very generic question, and you're right, it's a very subjective question. What makes a Pokemon better? So instead of saying who is better, I'm going to say who has a more powerful normal type attack. Oh my God. Much better. So a much better question. Yeah, a more precise question. So again, always remember, during deduction, there's some reasoning happening, right? If your question is very subjective, you're gonna get very vague answers, or you're gonna get answers which maybe is not relevant to you. So the more objective your question, the more precise it is, or the more explicit the question is on how to answer it, the better the answers are gonna be. So the earlier question, who's better, that's a very vague question, right? How do you define the word better? And that's a very valid question, Prashant. How do you define better? How does the model know what's the definition of better, right? Maybe it's possible that your definition of better and the model's definition of better is different. So let's get a more objective question, right? Let's get a basic question. Who has a more powerful normal type attack? This is simple math. We need to figure out the normal type attacks for both Pikachu and Charizard. And then we just need to see which has a more power level. And a power level is something which is given as an integer value, right? So the power level could be 50, it could be 80, it could be 100, it could be 150. It doesn't really matter. The point is, it's an objective question now. There's no vagueness associated with it. Make sense? Prashant, better question now? Does this work for you? But that's a good point. That's a really good point. Technically, yeah, we have an objective question. Sweet. We've got a one in chat from Prashant. All right. Now, as I said, the moment we start introducing any sort of vagueness, right? The moment we start introducing any kind of indeterminism, we start introducing the concept of agents. Right? We start introducing the concept of agents. So this can be rewritten as something like that. Right? This is nothing but your RAG pipeline. I'm going to write it like that. Right? And this, of course, is another agent. So I am gonna take the effort and actually do it the right way. Okay? These are agents. Now, again, you might definitely have this question that, Naren, why are we calling these things agents? Well, you know what? So why do we call these things agent? That's a good question. That's a really good question. But we're not going to answer that today. We're not going to answer why we are calling these things agents. Okay. I have a stream coming up, which is going to be comparing what different agentic frameworks are. Like, basically, I have a stream coming up, which is going to compare different agentic frameworks. I want to compare things like LangGraph, CrewAI, Origin, even Pydantic, and I want to pit them against each other. So we'll probably look at the question of what agents are in that stream a little bit in more detail. But for now, I think we can just look at agents as this indeterministic creatures of reasoning, which do one thing and they do that really well. Okay, so they're essentially they're essentially indeterministic functions, which are making decisions or handling indeterministic workflows, right? They may or may not be powered by LLMs, but that's besides the point. Mostly they're going to be using LLMs, okay? So we get to agents. We get to agents soon, and we get to comparisons between different agentic frameworks soon. For now, like I said, agents are just these indeterministic creatures which help you with reasoning, right? So planning things out requires reasoning. Deducing requires reasoning. Maybe you even have a validator out here, right? Validate the answer. Actually check if the answer is grounded or not. That's another agent. So these are all agents, okay? So what's the benefits that agents can technically give us? Let's start writing them down. So the first one is query decomposition. We just spoke about this, right? We just spoke about this. Did I just spell decomposition wrong? Decomposition. Wait, what? Did I misspell it? I have no idea. Crazy. But okay, query decomposition, we already spoke about it. We want to take a loaded question from the user, and break it down into sub-questions. That's query decomposition. So that's one of the things agents can help us with. What else? Query rewriting. This is an interesting one. This is a really, really interesting one. Sometimes we may not want to rewrite. We may not want to. Let me think about how should I put it. Sometimes we may not want to decompose the question. Instead, we want to rewrite it. For example, whenever you're working with a full text search database, like I said, it's keyword based, right? So instead of giving it proper sentences, it's going to be better to give it keywords, right? So you might want to take the user's question and try to extract the right keywords from it and pass the retrieval pipeline the keywords instead of the question. So in essence, you're rewriting the question. You're rewriting the user's question to make it a little bit more suited to get you a better answer. Don't worry. I do have an example of rewriting coming up. Okay, so rewriting, important. The next one is going to be query routing. Query routing. All right. Query routing is again a really important one. Okay. Technically, query routing is not specific to RAG. Actually, most of this is not specific to RAG. Oh shit, I just forgot something. Features, agents, bring to the table. I should write the title of the section at least, right? Okay, what is query routing? This is, like I said, this is really important. Like I said, there's no one pipeline or one retrieval pipeline which can solve all kind of questions. You will inevitably end up having multiple pipelines for different kinds of questions. Some questions might require agentic workflows, right? Some pipelines might require agentic workflows. Some pipelines could be really simple lookups in a vector database, right? Being able to decide between which pipeline you want is a very important aspect you'll have to consider eventually. The moment people start expecting more and more questions from your RAG pipelines, you will inevitably require some kind of a routing logic to decide which pipeline to use and things like that, right? So, yeah, right. And how do you route things? So you could route things based on the database. Where is your data stored? Is your data stored in like a full text search database or a graph database? Because vector databases are easier to query because you just need to pass them the query as is and they can pretty much work. But if you're using a graph database, that might require or a SQL database, that might require some agentic logic to convert the query into some kind of a SQL statement, which is passed to the database, right? So we're changing what happens in the pipeline based on where your data is stored. You might also need different retrieval strategies based on how you've chunked your data. Like for example, if you've just used simple chunking based on the chunk size, that's pretty straightforward, right? You just do a simple retrieval and you get done with it. But if you've done a more complex chunking strategy, like trying to identify the questions each chunk tries to answer, and then vectorize the questions rather than the answers. So whenever you do a vector search, you get the questions, and then through the questions, you can find the right answer. The point is, your chunking strategy can also change the way your retrieval works, right? And lastly, it's also just the data. What kind of data are you kind of storing, and what kind of questions are you trying to answer? So the point is, you're going to end up having a lot of different retrieval strategies, and having the ability to route between the different strategies and choosing the right one for each question. That's a really powerful feature, right? That's a very powerful feature. And that's what query routing technically lets you do, right? But again, like I said, this is not just for RAG. It could apply to any agentic workflow, but for now we're just gonna focus on RAG, right? We're just gonna focus on that. I think these are the major ones, but of course you could have more traditional use cases as well. Like, stuff we have been using agents for all this while. Like guardrails maybe, right? Making sure that the user's question doesn't have profanity, or they're not trying to jailbreak something or things like that. So you could technically have an agent to do guardrails. I mean technically you could even say that it's just a groundedness check or something like that. I mean, it could be very simple use cases. It could also be for enrichments. Enrichments, deductions, blah 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 blah. Simple basic reasoning stuff, right? So those are the advantage agents bring to the table. Okay, so now we know what we need to do to solve a question like this. We need to get inside. We need to start introducing an agentic workflow. And in the Pydantic stream, we already spoke about how you can build workflows with Pydantic. So we're going to continue with Pydantic. We're going to build this workflow with Pydantic. And we're going to see how to do each one of these using Pydantic. Sounds good? Give me a 1 again. Give me a 1 in chat if you guys are with me. I swear the word agents could literally mean anything these days. That is so true. I mean, it's such a vague thing. Like, what agents mean, it's such a vague thing. I do have some thoughts on it, but I think that's a topic for another stream. Otherwise, this will be never ending, right? Sweet. All right, cool. So let's look at the code base. All right. This is too big. So how can you use a RAG pipeline? How can you enable an agent with the capability of RAG? Let's try to solve that question first. So let's try to solve the question where we essentially figure this out. How would this agent look like? Because technically this is an agent as well. How would this agent look like when we talk Pydantic? Okay. So any of you, like anybody who's probably new to Pydantic, they've not seen it before. Again, a video on Pydantic just went out, I think a day ago, like yesterday, maybe a day before that. And it talks about Pydantic in a lot more detail. Okay, we really get into like depths of it. So for this one, we're just gonna build on top of it, right? But just some basic understanding of how Pydantic works. Essentially, you need to install Pydantic AI as a library, and then it gives you this OpenAI model, right? So whenever you read the word OpenAI in my code base, don't think of it as literally OpenAI, okay? I'm an open source guy. I use open source models. Whatever we're gonna achieve today is using cheap, off-the-shelf open source models. So if we actually are able to solve this question of comparing different Pokemons together, we technically solved it using open source models, which would be amazing. That would be crazy. But okay, so you create, this is essentially the driver. So we're using the OpenAI driver, and then we create an agent object, right? In the agent object, we'll pass the model as is, and then we give it a system prompt. So here, essentially, I'm saying that, hey, you're a helpful AI assistant. Help me get the right information to answer the user's question. And then what we're doing is we are registering our RAG pipelines as tools. That's one way to do it. One way to make agents RAG capable is by registering your RAG pipeline as tools. So I've got two tools here. So one tool is perform similarity search. Perform similarity search. What it does is it takes a query as the tool's parameter, and under the hood, it's essentially just calling your vector search function. What is vector search doing? It's connecting to LansDB. It's creating an embedding from your query, and then you basically do a vector search and get the result back. Essentially, that's what you're doing. And we're trying to get the top K results. In this case, the top K is 10. Fairly straightforward. And then we try to create a context object from that result, right? We create a context object where I'm just taking those different chunks which we got and combine them into one master chunk. And in my one master chunk, I'll make sure that I have the file names and the context for each one of my sub chunks, just so that there's a little bit of context there. We saw all of this in the RAG pipeline, and now we just merged it, right? So one way to do this is by tool calls. And of course, I have another tool call as well. So I've got another tool call for keyword search, which is pretty much the same, but instead of doing a vector search, we are doing a full text search, right? That's the only difference. And again, LansDB helps us with both, and that's the reason why we are using it. Pretty straightforward, right? It's nothing fancy. It's just a tool call. So the model doesn't even know it's doing RAG. All the model needs to know is that, hey, we need to nudge the model to say, hey, you need to find the right information, and you have two different ways to do it. One is similarity search and one is keyword search. That's pretty much it. Now, just because we're talking about Pydantic, there's one annoying aspect of Pydantic which I need to talk about. Pydantic by default, what it does is, actually, you know what? Let me go back. What Pydantic does is, whenever it decides it wants to call a tool, it will go ahead and call the tool, but it will also try to prompt the model again to summarize the result. So Pydantic by default keeps calling the model till the model decides that I have no further tools to call, which is not too big a problem if you're using something like GPT-4o or something. But in open source models, it's a big problem, right? So I do not want to continue once a tool has been called. Once I've gotten the context, the agent's work is done. The agent's responsibility is just to get the right context, and that's pretty much it, right? So the way I fixed this, I had to go in the library and then, I had to finalize the result manually. This is one hack we had discovered or we had explored in the previous stream. I'm just doing the same hack again because they still haven't merged the PR which fixes this issue. Again, this issue will be fixed. They have an active PR which is gonna allow your tools to just end the agent's lifecycle right there and there. It's just not fixed yet. I know it's such an ugly workaround, Prashant. I know it. It's super annoying. It is so frigging annoying. But hey, they're working on it. There's a PR. They will be fixing it, right? It's a PR. So yeah, this is one way to do it. So how does it look like? Let's open our terminal again. Cool. Let's clear the screen. And then, yeah, let's just run that pipeline, right? So the way we use this agent again is very straightforward. We just have a query and then we just tell the agent that, hey, run this query. That's pretty much it. That's how you use it. It's pretty straightforward. The experience of triggering an agent is pretty straightforward when in Pydantic at least. So yeah, that's pretty much it. So all this guy did was the agent decided that, hey, you know what? It wants to perform the keyword search. And that tool was invoked. Now I'm not printing the actual context which got returned because that would be a lot of logs, but you can trust that, hey, my tool goes ahead and fetches the context. You know what? I know you guys will never trust me. You guys are cruel. You guys are very cruel. So let's print it. Result.data. Cool. Let's run this again. It's gonna be like a lot of, it's gonna be a very verbose output. There you go. Super verbose. Sorry about that. Oh my god, how much is it? Was it 10K or 20K? Wait, I think I'm just scrolling up and down. Okay, it doesn't matter. This is like super verbose. I'm not going to the entire thing, but you see it, right? We're getting our chunks and we're getting the file name and we're also getting like the moves which Pikachu had and things like that. Again, technically, you decide the scope of the agent. So you could potentially decide that, hey, after getting the chunks, I want to go ahead and even extract the final answer from it. Okay? You decide the scope of the agent. For me, the scope of the agent right now is just going to be get the context back. Just get the context back. Don't really use your head to find the right answer within that context. I don't want this agent to be doing it. Okay? Because if you think about it, it's going to be a separate model prompt anyways. So I would rather have a specialized system prompt to extract the relevant information and a specialized system prompt to call the tool to do it a little bit more in a more efficient manner. Because I could have a smaller model to do the tool call, and I could have like a better model to find the right data within all that context. Right? It's up to you. You could have one agent do both of them. I prefer having them as separate agents. Make sense? I hope you guys are with me here. That is one way to do it. Now I know some of you are thinking about this. Okay, you know what? I know some of you are thinking about this that, hey, you're making an AI tool call, which means you're prompting the model before you can even touch the retrieval pipeline. Isn't this going to add latency? Yes, it is going to add a lot of latency. Using agents or using LLMs to do anything will add a considerable amount of latency. Now, I will say that there are a lot of vendors which are working on making models even faster, which is great. I really appreciate their work. But it's going to be more than nothing, right? You're still making an LLM call. So I will be having another stream. I will be having another stream, which is going to be talking about how you build user experiences to deal with such agentic system, because our applications, our user interfaces have to evolve to keep in mind the latencies and the indeterminism of agents. So how do you decide, or how do you design user experiences on the front end side of things to combat such issues from an experience perspective rather than a technical perspective? So we're going to have a stream on that as well. Sweet. Cool. That is one way to do it. Sweet. That is one way to do it. Use, call your retrieval pipelines as a tool call. What is another way to do it? Another way to do it is, this is interesting. I've not seen a lot of people talk about it. I'm not sure even if it's a good way or not. So Prashant, Ashaya, and everybody else in chat, tell me what you think. Okay. Actually, a big disclaimer. Again, a big disclaimer. A lot of the stuff which I'm going to be talking about today, and I have been talking about, especially when it comes to Agentic RAG, is very experimental for me. I haven't worked a lot in this space. So I would really appreciate your comments and give me feedback so that we can collectively come on an opinion on how to use this framework in a better way, right? So I would really appreciate that. Actually, Prasad, you know what? You can take this part and maybe put this up ahead in the final video because I think it's a good disclaimer to start with. Whatever, cool. The second way to do it is using a system prompt, okay? Now, this is very Pydantic specific, but I mean, you could technically do it with any agentic framework. What I'm doing here is, if you know the query up front, actually, let's take a step back. I'm sorry about this. Let's take a step back. I think we need to talk about this one thing. Whenever you're using retrieval as a tool call, you are inevitably doing a query rewrite. You are inevitably doing a query rewrite, right? Because if you even look at the logs here, oh shit. Yeah. If you look at the logs here, the original question was what are Pikachu's electric type moves? But the actual question passed to the tool was Pikachu electric type moves. It's more keyword focused because we are doing a keyword search. So the query being passed to the database is different than the original query. So one advantage of tool call was you're getting inbuilt query rewriting, right? The model took the decision of rewriting the query to optimize it a little bit better for keyword search. And of course, you could have rules around how it should optimize it as well in your system prompt. I didn't do that, but you potentially could do that. So you're getting query rewriting by default. Not just that, I'm not sure if you guys realized, but I have two tool calls, right? So the AI took the decision, the agent took the decision of doing a keyword search rather than a semantic search. So not just did we get query rewriting, we also got query routing. Very important to keep in mind. So tool call, it's not just adding latency of, deciding what tool to call. It's giving you some additional characteristics of features which could really help out. On the other hand, we have the ability to introduce the RAG pipeline as a system prompt instead. So if you know what the query is, and the query is precisely the same query that, if it's precisely the same query that needs to be given to the model, then you don't need to do a rewrite. We don't need to do a rewrite. And I think we have a very relevant question here. Do you find that query rewrites are really good? They always seem to search oddly to me. Query rewrites is very tricky, but it really depends on your retrieval strategy. If you're talking about vector search is already such a vague searching mechanism, right? It's so indeterministic. So you'll never know whether rewriting the query is really going to give you the benefit or not, right? So doing rewriting on vector search may or may not have a better output. Decomposition instead would have a much better output, like breaking down a complex query into smaller, easier queries. That's going to have a much better output, and we probably will try to see that. Rewriting, maybe not. However, when you're talking about full text search, like I just showed you, because full text search inherently doesn't care about the phrase. I mean, it does care about the phrase, but it cares more about the keywords and the structure of the phrase rather than the semantic meaning of it. The way you pass the query to the full text search engine is gonna influence what results you get back, right? Like Google. In Google, even if you put in just the keywords, you're gonna get an answer back, right? Because Google does use some form of full text search plus graphs under the hood to give you the answer. I mean, it's really complex. I'm not gonna assume or even gonna pretend that I know it, but you get the point, right? Rewriting could have different benefits based on what kind of retrieval strategy you have. The more you go towards deterministic strategies, the more does the phrasing of the query matter, right? The more, again, I don't have an absolute answer for you beyond. I don't have an answer. I'm sorry about that, because like I said, I'm still very new to this agentic RAG space. I'm still very new to query rewriting. But in the initial testing which I've done so far, query rewriting gave me better answers for full text search rather than for vector searches. That's literally all I have for you. But that's something we should experiment. Definitely join the Discord. Join the Discord and we can check these things out, I want such topics. I want topics, we can dive deep into and literally figure out what's going on and how to make things better, right? And even fabricate examples to get to those answers. That would be fun. But okay, coming back to this. RAG in system prompts. So what I've done in this case is, again, I'm assuming that the query that the user passed is the perfect query. Okay? I'm assuming that the query the user passed is the perfect query. So, and I know exactly how to process that query. So I don't need query rerouting, and I also don't need query rewriting. Oh my God, say that fast. That's crazy. Okay, you don't need query routing or query rewriting. All right. In such a scenario, you can skip the tool calling phase altogether. So what I've done is Pydantic gives me the ability to do dynamic system prompts. Pydantic gives me the ability to do dynamic system prompts, right? So all you need to do is register a system prompt. So I've registered this function. And what I've done is I'm taking the user's prompt and I'm just performing vector search myself. And I'm creating a context from it. And then what I'm doing I'm shoving that context into the system prompt. And this string which gets returned will be appended to this system prompt. Does that make sense? Are you guys with me? This is what I'm doing. I'm doing the vector search, or I'm calling the retrieval pipeline as a part of my system prompt generation process. So we don't need to do a tool call anymore. We are preemptively calling the retrieval pipeline, getting that context and shoving it in the system prompt upfront. All right. Very interesting. Very interesting. So let's try to see how this works. Oh, sorry, I need to open the terminal, right? Let's clear all of this mess. And we need to do the second one. Right? So again, there's no query rewriting that's going to happen. It's straight up going to go ahead and figure out what Pikachu's electric type attacks are. And it's going to give us an answer. And it did give us an answer. Thundershock, Thunderwave, Thunderbolt. It kind of missed one, but that's fine. We're not looking at the query performance here for an individual pipeline. We're looking at the larger concept, right? Like I said, the pipelines are going to be super scuffed, okay? They're not going to give us the best results. Apologies. Just bear with me for that one. So the advantage here is we got the final answer. So we did not just get the context. We got the final answer in a formatted way in a single prompt, right? In a single inference call. In the tool call example, we would need a minimum of 2. We would need one prompt to identify which tool to call with what parameters. And then we would need a second prompt to identify the relevant sections in that context and, format it nicely. Here, we got the answer in a single query upfront, right? I mean, if latency is a huge problem, I think this is a good solution. But again, it's very limiting and you would definitely need to have some kind of routing step in front of this so that there's one agent which can decide that, okay, forward the request to this agent and this agent will have a very narrow scope of work. It's going to be like, hey, I can only answer questions like this. But if you give me a question which, comes under this criteria, like, straightforward, talking about Pokemon, something like that, I'm going to give you an answer straight up. I'm just going to shove it in my system prompt and give you an answer. So pretty cool. Not super flexible, but cheaper and faster. I like that. Now, while I was doing this, I thought that these two are going to be it, right? I mean, there are just two ways to do it. But a friend of mine asked me an interesting question. The question was, when you're doing vector search, you can technically do some kind of filtering as well. Let me show you what I'm talking about. Vector search is not just similarity search, right? I mean, it is, of course. What am I saying? Vector search is similarity search, but as your data corpus grows in size, it makes more sense. Oops. Wait. Yeah. It makes more sense. Once your data corpus grows in size, it makes more sense to start adding in where clauses, like what I'm doing here, right? I'm essentially adding a where clause to my query, right? And this is really helpful because it limits what chunks will even be looked at, which speeds up the query considerably, and it will also make the quality of your top K much better. Because if you're searching a vector database with thousands of Pokemons, you're not guaranteed that you'll get the right Pokemons in the answer if you just want 5 chunks, right? But if you restrict the chunks to just a particular Pokemon by adding like a where clause, like what I'm doing here, I'm restricting it to a particular Pokemon. In that case, you're going to get much better answers, right? Because whatever answers you get are definitely going to be related to that one single Pokemon. So the quality of the chunks is just going to go through the roof. At the same time, it's going to be faster because you don't have to go through the entire vector space. And an interesting thing which came up to solve that is combining the two strategies we just saw. Including RAG as a part of your system prompt and including RAG as a part of your tool call. Hear me out, okay? Just hear me out. This is going to be a little interesting. I have an agent here, okay? And again, I have a tool call as well. But I've made one slight change in my tool call. I've said that, hey, give me the name of the Pokemon you want me to do the search for, okay? So this retrieval pipeline is designed to work for just a particular Pokemon, okay? Pretty sweet, right? The model, all it has to do is just give me the name of a Pokemon. And what I'm going to do is, in my vector search, I'm going to use that Pokemon as a filter. But the problem which I faced in this approach was that how will the model know how is the Pokemon stored in my database? How does the model know the values of the fields which I want to filter on? Right? In this case, okay, it's fairly straightforward. I can just, use the word Pokemon and it might just work. But wouldn't it be great if there was a better way to identify what are the values or what is the complete set of values which we can filter on, and then tell the model that, hey, you know what? I have this filter called Pokemon, and this is the valid set of Pokemons which you can filter on. That would be amazing, right? And to do that, I included a dynamic system prompt. What I did in this dynamic system prompt is do another query. Now, this is technically not a retrieval query. This is not doing a vector search. Think of this as a structured query. This is a structured query which is getting me the list of Pokemons which are available, right? And essentially, I'm taking the list of Pokemons and I'm appending it to the system prompt. So what I'm doing now is I'm saying that, hey, I've got two tools. One can do the similarity search and one can do a full text search, okay, or a keyword-based search. Call these tools. But you have this filter called Pokemon with you, so you can use a filter as well. And by the way, the possible list of Pokemons that you can use is in here, is in this list. Does that make sense? Are you guys with me? Does that make sense? This was kind of like a revelation for me. It might be really obvious for you, but give me a one in chat if this seems interesting. If you follow me, if you're with me, or give me a two if this is a big L. I mean, if it's an L, I'll take the L. But I have a feeling that, this was a pretty interesting way, a very interesting way to tell the model that, hey, these are the possible filter values I have. Oh my God, suddenly all the freaking chats just came at once. There's something weird going on with YouTube. Something really weird going on with YouTube right now. But okay. Do you find rewrites? Okay, you read my mind, been waiting. Metadata filtering. Prashant, you were the friend I was talking about, buddy. You are the guy who inspired this. This approach falls apart if you have an entire database of anime, Pokemon, movie, and more. Exactly, yes. There are cons of this approach because I'm trying to give an exhaustive list of all Pokemons. But if you have like 100 different Pokemons, this is not going to work. This is definitely not going to work. So I'm not saying this is the answer or this is the way of doing it. I think this is one of the things we can explore. Because if we implement some kind of a retrieval strategies to create a subset of the Pokemons we need, we might have a better way to do filtering, right? Alka has a question. I have a generic question. Oh, what if we have a generic question like what are the fire, like give me all the Pokemons which have fire type attacks, right? Yes. In this example, Alka, I have written the agent to give me answers for a particular Pokemon. That's my use case. If you wanted a more generic form, like a query which could span multiple Pokemons, either make this field optional. So give the model the ability to decide whether or not it wants to pass the filter. It doesn't always have to pass the filter. You can make it an optional field. Or you could just have a separate agent which, doesn't do filtering at all. That is completely up to you. Filtering is not a mandatory step. You can always have optional fields. Like this one. Oh my God, cursor is so good, man. This tab completes of cursor, it's crazy. Oh my God. Yeah, I love cursor. I'm sold on cursor. I'm using cursor for life now. But yeah. So the answer to your question, the Pokemon has to be a fixed parameter which has to be passed. It could be an optional parameter. And again, you rely on the model's reasoning to decide whether or not Pokemon needs to be passed. In my case, I'm keeping it simple. I'm going to say that, hey, I always want to filter it based on a Pokemon. Just, I'm just getting some nuances. I just wanted to demonstrate an example of combining this system prompt with the tool. So you could basically have a lightweight retrieval query to populate some aspects of the system prompt, which can help the AI model call the tool with the right parameters. That's essentially what I'm trying to sell here. That's essentially what I'm going to sell here. Cool. All right. Sounds good. So that's the third approach. Let's run it. Yeah, let's run it. Why not? Clear. If I run this and it's going to be to C. Yep. Let's run this. Come on, buddy. You can do it. Yeah. So it called the tool. See what it did now. Now this is the power of rewriting beyond. This is probably going to answer your question. This is what I noticed. My question was, what are Pikachu's electric type moves? The query here, you know what? Actually, I should rewrite it. Let's make the logs a little bit better. Yeah. Let's run it once again. Let's run it just once again, guys. Just once again. Yeah. Come on. You can do it, buddy. Oh, did I just run the wrong thing? What did I just do here? Did I mess something up? Oh. And I don't want the results. Please don't give me the results back. I'm not printing the results, man. That's crazy big. It's so huge. We're gonna run it once more. Hopefully this is the final time. What are Pikachu's electric type moves? All right, sweet. Go ahead. Now it called the model. It's doing a keyword search, but look at the query it passed for the keyword search. Electric type moves. So the model was smart enough to understand that, hey, I'm going to do a filter on Pokemon using the word Pikachu.md, because remember, technically it's not the Pokemon, it's a file, right? So we want to filter on files. So yeah, Pikachu.md, that's the filter. But it rewrote the query to just be electric type moves. So instead of, saying Pikachu's electric type moves, we're just saying electric type moves because we're already doing a filter on Pikachu. So we don't need to put Pikachu in the query itself. It's fine-tuning the query to the best of its ability beyond. I think we should give it props. We should give it props. Quen is doing a good job here. It's doing a good job here. Oh my god. But yeah, that's query rewriting in action, and this is also an interesting side effect of trying to add filters and stuff. It's cool. I don't know. Cool stuff. All right, so we've answered the question of how you can include agents with RAG. So I think we now we know how to make our agents RAG capable. Nothing fancy. We're doing simple tool calls, right? Or we're shoving things in the system prompt. It's not really all that fancy. Now let's try to get to our final answer so that we can architect or design a workflow to solve this particular question, right? Who has a more powerful normal type attack, Charizard or Pikachu? Right? That's my question. So of course we are going to have like a planner agent. The planner agent is going to decompose this. The planner agent is going to decompose this question into sub-questions, right? Then we're going to have a loop. We're essentially going to have a loop. Agent retriever. So we're going to have a retriever agent which works in a loop. So, let's make sure that I write it down. Oops. Right? It runs. The retriever agent will run once for each response in the planner agent. So the planner agent said, hey, we need to decompose this into 3 questions. We're going to run the retriever thrice. All right. And then of course we need to deduce the right answer. So we need the deduction, but I totally forgot about this. We're going to have an extractor as well. Because remember, my agents my agents don't just get the context. They don't really summarize the answer. Okay, that's what my agents do under the hood. So what I need to do is, I need to have like a second agent, which is like the second prompt, to take that context and create a more concise context out of it, right? And then this guy will essentially get a list of the output of this guy. So essentially, this goes here. A list of context objects. You get the point, right? You guys are with me, right? Oh my God. The amount of mileage you're getting out of a little 8 billion parameter, it's crazy. No, so I'm not using an 8 billion parameter model throughout. So if you look at this, if you look at my agents, whenever I say model medium is a 32 billion parameter model, right? It's Quen. I'm using Quen. And my model small is the 8 billion Llama 3.1. But yeah, I mean, these are pretty good. I'm not gonna lie. Decent output, man. Decent output. But yeah, all the models are below 32 billion. I don't know. I just had a restriction for myself that, hey, you know what? Let's try to do this with small models, and kind of works, kind of doesn't work. Cool. So this is how our pipeline will look like. We're gonna have a planner. Then we're gonna iterate over each question the planner spits out for us, and then we're gonna call the retrieval pipeline, and we're gonna summarize the output of that retrieval pipeline. So we have concise summaries for each question, and that concise summaries is gonna go to the final agent, which will deduce the right answer. So how does this look like in code? Wait, you guys are with me? Give me a 1 in chat. Give me a 1 in chat if you guys are with me. Like, we understand the architecture, right? It's pretty straightforward. If you were there in the Pydantic talk, this is actually kind of easier than the previous one, I feel. Okay, you guys are with me. Sounds good. Sweet. All right. So how did I do this? Let's look at the various agents which we just spoke about one by one. Let's start with the planner agent. Okay, let's start with the planner agent. The planner agent, again, it needs to do reasoning. It needs to decompose the complex query into an easier set of questions. So I'm using a medium model. I'll be very explicit with what model I use now. So I'm using a 32 billion parameter model for this. I've given it a system prompt that, hey, you're a helpful AI assistant. You need to break up the user's question into smaller groups of questions. Each question should be a standalone question that does not depend on the answer of, right? Of any other question. And try to group related questions together so that you can keep the number of questions to a minimum, essentially, right? Pretty straightforward. But I want structured output. Remember, I want to do a loop around it. Now, Pydantic does give a structured output. Pretty straightforward, I'd say. I mean, technically, this structured output is so simple that I wouldn't even use Pydantic for such a use case. But hey, you know what? It gives it to us, so we'll use it. Okay. So I have defined a result class. I was just gonna call it a struct. A result class, which says that, hey, okay, I need a list of sub questions, right? Which is just a list of string. Pretty much it. Nothing fancy here. And then I'm telling Pydantic that, hey, give me the output in this class. But if you guys remember, Pydantic implements structured responses using tool calling, which throws open source models. It confuses open source models a lot. So what I've ended up doing here is that I have taken control of the tool name which is sent to the model. So by default, it calls it something like final result, which is very vague. So what I'm saying is that, hey, agent, you have a tool called sub questions. This tool is basically a list of sub questions to ask to the user to retrieve all relevant information. This is a tool you need to call to give me the list of sub questions. Essentially, I'm conditioning the agent to do a tool call, which is slightly annoying if you ask me, because now I have to write an agent in a form that it's supposed to do a tool call instead of a structured response. which is not something we're used to doing, right? This is not even something which open source models are designed to do. So it's forcing you to think in a way which is not relevant to what the use case is. I don't really like this a lot, but hey, it is what it is, right? Just remember this: whenever you're using structured responses using Pydantic AI, it's doing tool calls under the hood. There are pros and cons to this. We already spoke about the cons. The pro would be that because it's just doing a tool call, you're guaranteed that if you get a response, it's definitely going to be structured, because most inference backends have got strong implementations for tool calling at this point. So you know that the schema is taken care of and things like that, right? But don't forget this. Pydantic does give us the ability to register result validators. So you could do something like this. You could always do something like this. No, returns result. Yeah. You can always do something like this and basically say that, okay, if the result how do you do length in Python? You do something like that, right? Yeah. If length of sub questions is equals to 0, retry. No question sub questions found, do a retry. This is the only feature, or this is the only reason why I love Pydantic structured responses. Like if you wanna validate your data, not just the shape of the data, but the contents of the data itself, what essentially you can do is you can say that, okay, register result validator. The result validator gets invoked whenever you have like a structured response. But now you don't have to worry about the shape of the data anymore, because you're getting a result object straight up, right? You can straight up do length. Like you can straight up check the length of the sub questions. If it's 0, try again, right? If not, result. Oh my God, are you guys grilling my Python skills? What are you guys doing? Sure. Okay, wow, Cursor just did it for me. Thank you, Cursor. But yeah, sure. You get the point, right? So Pydantic will automatically retry and make sure that whenever I get an answer from this, it will always have more than one sub question, which is really good. I really like this feature. I genuinely really like this feature. So you know what? I'm going to keep it in. So yeah, that's how you do structured responses in Pydantic. Nothing to do with RAG. This is just our planner. So at this point, we'll have a sub questions. Now, the next thing we need to do is the retriever. Retriever, we've already seen this. It's the same agent. And I have a dynamic system prompt which gets the names of the Pokemons, right? It gets the name of the Pokemons. And then I've got two tools, one tool for similarity search and the other tool for a keyword-based search, right? So we've already seen the retriever tool. We're using the combined version, right? We're using system prompts and we're using tool calling. But because my agent doesn't summarize the result, we'll need some kind of an extractor or some kind of a summarizer, right? Again, very straightforward. This is just an LLM call. All I'm saying is that, hey, give a good answer to the user's question. But again, this is not the user's question. This is technically the sub question which the planner came up with. But the model doesn't need to know it's not the user's question, right? For the model, the sub question is the user's question. So I'm saying that, hey, just summarize this question for me. Pretty straightforward. Nothing fancy going on here, right? The last thing we need to do is the deducer. The deducer, that's just so weird. What did I call it? I called it the finalizer. Yeah, I remember giggling away to the word deducer for some reason. I don't know. I'm a weird guy. I'm a really weird person. So I renamed it to finalizer. Cool, we'll call it finalizer. Again, finalizer is not doing anything much. Just give me an answer. Now, to be fair, at this point, I was getting late for the stream. So the quality of the system prompt is going to drop as we proceed forward. I've not even tested if this actual pipeline works or not. I've just written the code and we are going to test it together. Surprise, surprise. So how does the workflow look like? This is the workflow. We start with the main query. This is the main query, right? Between Pikachu and Charizard, who has a more powerful normal type attack, right? Straightforward. Then we go to the planner agent and we just hit run sync, right? So we take the query and we just give it to the agent straight up. However, there's a typo. Who has? I mean, models are good, buddy. Models are pretty good. Don't underestimate the power of Quen. That's a good one. Make a shot out of that one. Okay, I'm kidding. So you first give it to the planner agent, and because we have structured responses, remember, Pydantic is type safe. All I can do is, I just need to do sub questions. Oops. .data, and I have this right here as a list of string, which is pretty cool, right? It's so cool. I really like that. And at this point, you are assured that this is always going to be a list of string, and it's going to have at least one sub question, right? Just because of the way we've written our planner agent, that's some guarantee which you're going to get. The quality of the question is still a toss up. We don't know that yet, but we definitely know that, okay, we're going to have a list of sub questions, and there's going to be at least one in there, just because of a result validator, right? Then what do? I just put a for loop in. I just, do a for loop, and essentially I call my retriever agent, right? But this time, I'm not going to give the original query. I'm going to give it the sub question. So the retriever gets my sub question, right? We might want to comment that out. Once you get the sub question, now you need to extract the main question out. Now this is now territory where I don't like Pydantic. The problem is Pydantic doesn't give me a way to modify the user's prompt. So I need to create the right prompt myself outside the scope of the agent. So technically what I have to do is create a prompt which says that, hey, this is the sub question, and use this context which we got from the retriever to find the right, to extract the right context from all the chunks which we got out. I don't like this. I would have to do this every time I want to use the extractor agent anyways, right? So shouldn't this prompt be embedded within the agent somehow? That's what Landgraph lets me do. But in Pydantic, because Pydantic doesn't allow me to modify the user's prompt within the agent, there is no way for me to just take the sub question and to just take the context as dependency and formulate the prompt myself. I can't do that. I will have to formulate the prompt myself over here, which is super annoying. I don't like this. There are ways around this. Like I said, you could use dependency and give the context within the dependency. And you can also use a dynamic system prompt to take this context and put it in the system prompt instead. You can do those kind of things, right? It's just a little annoying. L is better than Pydantic in this regard? Definitely. I think most of the tools which are unopinionated and very minimalistic are going to be better than Pydantic. The fact that Pydantic is creating an agent wrapper and it's controlling how the agent works, like how the core of the agent is written, there's going to be some limitations on custom functionality, this being one of them. Having said that, you could technically just pass this agent as a dependency to Pydantic. So I could have technically said dependency is equal to retriever and just pass the retriever agent here. And then in the system prompt, I could use the retriever agent to run this, to invoke the retriever agent and populate the system prompt directly. But again, all of it would go in the system prompt. Technically, what I'm trying to say is I would not have to call the retriever individually. I could basically call the retriever within the extractor. I could have done that by using dependencies. I can technically do that. But hey, I want to be explicit here. I want to be explicit that, hey, I'm calling a retriever and I'm calling the extractor separately. I just want to do it that way. But hey, maybe dependencies would be a better way to do it. Actually, you know what? Do you want to see that example? Do you want to see how we can combine both of this into a single agent? Like instead of calling the retriever separately and the extractor separately. Do you want to see how we can combine this together? Meanwhile, I have another question. Does Pydantic AI not have the concept of a user prompt? Technically, it does. Pydantic does have the concept of a user prompt. And we are using it, right? Oh, we're not using it here. Where was I using the concept of a user prompt? Oh yeah. You do have the concept of a user prompt. This. So like whenever you're doing dynamic system prompt generation, you can use the user query which was passed. Whatever you pass in this run sync, that's the user's prompt. That is the user's prompt, right? And you can use that to populate the system prompt. I think they have a PR to allow you to modify the user's prompt within the system prompt, but it's very convoluted. I don't think so they have a first class support for it. At least it's not in the documentation. But yeah, technically for Pydantic, the thing you pass in the run sync method, that is the user's prompt. And that is the reason why I was going ahead and creating this prompt myself before passing it to the agent. Yeah, the API is not good. The moment you want to get into some custom territory, the API starts getting ugly, like this one. But having said that, you know what? Let's do the same thing in a different way. What I could technically do is, I could create like a data class and call it extractor class extractor dependencies. Let's just call it deps. And this is essentially going to be a retriever agent. Yeah, this is just going to be a retriever agent. Now what I can do is, I can say that this agent expects some dependencies, which is extractor deps. Deps type, my bad. Okay, cool. Now what's the error? Cool. Now what I can do is, I can give it a dynamic system prompt. So I can say extractor. Oh my God, it's so difficult to type when you're conscious that people are watching you. Yeah, now what you could do here is, you could essentially say that I want to use my retriever agent and, run that prompt, essentially, run that question, whatever prompt we give it, get the result here, and then pass that result at the system prompt, right? Again, I think this is more convoluted. That's the reason why I don't do it. But what this will let us do is, instead of calling the retriever separately, I would be able to technically do deps equals to extractor deps and retriever agent goes here. So what I can do is, based on what kind of retrieval strategy I want, I can pass it the right agent, and extractor would take care of calling the right agent internally. So yeah, you could combine both of them together. I don't like it. I think it convolutes things a lot. I don't really like it at all. So I'm gonna undo whatever I just did. So we're gonna remove this. We don't need that. We don't need this either. We don't need that. And we're back to normal. Yeah. But yeah, that's something you could have done. Again, I'm not saying that's the best way to do it, but technically you could do that. We have another question. I have never tried L. Actually, overall thoughts. L is pretty good. It's pretty minimalistic. Hey, come on. Hey, Prashant, come on. Hey, come on. I don't have any affiliates to Pydantic. Okay. The real reason I started doing Pydantic and I'm making content on Pydantic is because it's trendy. It's working on YouTube. And I'm running a YouTube channel. I want views, guys. I want views. And that's why I need to make videos on topics which are more popular. But L is essentially a very minimalistic prompting tool. It's a library. It's not a framework. I wouldn't call it a framework. It's more like a library. And it's got a very opinionated way of crafting the system prompt and stuff. It has no concept of an agent. So it's not an agentic framework. I would not call it an agentic framework. Though you could make an agentic framework on top of it if you write some of your own code. But that's the point of L, right? It's basically a prompting tool from what I understand. And it has no opinions, which means you can craft your own agents on top of it. That makes sense. But again, Prashant is a person who's been using L far more than I have. So maybe Prashant, we could have a talk just on, We could have a stream where you come in as a guest to talk about L. So L has a minimalistic yet highly opinionated API. That's true. It's not an agentic framework. I totally agree with that. L can play well with other agentic frameworks. Again, L will not work with Pydantic because Pydantic has its own way of controlling the prompt. Pydantic controls what gets sent to the model, right? So you cannot use L with a framework like Pydantic. However, any agentic framework which doesn't have an opinion on how you talk to the model, like LangGraph, you can use L with those kind of frameworks. So LangGraph lets you control how you talk to the model. So you could, in theory, use you could use L within LangGraph, if that makes sense. Don't worry. In the talk where I'm going to be comparing different agentic frameworks, I will be talking about all of this. This requires a separate stream. This is a deep topic and we'll have to go deep into the mindset of every framework. And I keep saying this, there is no best framework. There are only frameworks which suit your perspective, your opinions, right? So if you relate with a framework's mindset, use it. Like for example, me, I absolutely love the way this works. I love this concept of, structured responses and having a hook to validate things. So whenever it comes to a little bit more complex system responses, I'm going to use Pydantic. But does that mean I use Pydantic in my entire app? No, that's not what I'm trying to say. I will be using LangGraph. That's still my favorite framework. But for structured responses, I think I'm going to go towards Pydantic if I have some more complex structured responses cases, because that result validator, I love it. It's really good. Similar for tools. For tool calling, there are some things in Pydantic which are really good. I just love that retrying ability and, the dependency injection and things like that. I just love those things really much, like a lot. So again, Pydantic is not the framework you can make your complete app in. That's for sure. Like you just see this, right? This is not good. I don't like this. LangGraph would be a better thing for this. But again, we are not here to diss on Pydantic. Prashant, don't do that. Stop doing that. This is a talk on Pydantic. Okay, we're using Pydantic. Please, come on, let's stick with it. Sanket, hi Sanket. Good to see you on the stream. I think you're the first time chatter, but you have another question. Any tips on choosing a model for agentic framework? I think it doesn't matter. It depends on your task. Like I'm using a 32 billion Quen 2.5 and I'm using a 8 billion Llama 3.1 and I'm getting decent-ish results, right? So it really depends on how you use it, how do you craft your system prompts, and what use case are you trying to solve. Cool. Let's continue, guys. Let's continue. Let's start with the implementation again, because otherwise my editor is going to have such a hard time in editing that section out. By the way, editor, we're going to have a ton of shots in the previous section. So, but let's start the implementation again. Okay, let's start the implementation again, and then I'm gonna look at your messages. Okay, I just want to run through the implementation in one shot, so it's easy to cut this out in the final video. So, how would you implement all what we just discussed? Right? We already spoke about the different agents we have. Now let's look at how we can build the workflow. So I'm starting with my query. My query is between Pikachu and Charizard, who has a more powerful normal type attack? Maybe there are typos, maybe there are grammatical errors, it doesn't matter. Now we're going to pass it to the planner agent, okay? Because the planner agent is going to decompose this query into sub-questions. And because our planner agent had that result validator, we can be rest assured that sub-questions is definitely going to be a list of string. As you can see, my LSP or whatever Python uses, it's telling me that, hey, this is typed. Sub-questions will always be a list of string, and it will have at least one. It will have at least one sub-question. Because remember, we have this result validator right here, right? So once you have that in place, we have a list of sub-questions. Now we get into the loop. For every sub-question, we're gonna get the context, and we're using another agent for this. Technically, if the sub-question was, if you could pass the sub-question directly to the retrieval pipeline, you don't need to use an agent. But like I said, I want to use the query rewriting capabilities. I want to use the query routing capabilities, right? I've got two pipelines, one powered by full text search, one powered by vector search. It could have been a single pipeline, but hey, just go with me, okay? My stream, my rules. Right. So I'm using an agent for that. So this gets me the context. It's not the summarization, it's just the context, because that's what my agent does. It just gets the context. Then I have an extractor. The extractor, now this is the ugly part of Pydantic, like I just spoke about. Because Pydantic doesn't allow you to modify the prompt directly, you will absolutely have to create your prompt yourself, which is really ugly. Technically, if you're creating an abstraction for an agent, the way the agent needs the prompt to be crafted should be within the scope of the agent. So this is a leaky abstraction because you need to make the prompt outside the scope of the agent. The only way to get around this would be to take this data, shove it as a dependency, and shove it in the system prompt. So you can use dynamic system prompts so that, that's one way to solve it, so that you can pass the question as is. But again, don't force that opinion on me. I would really like to control where I want to shove the context. And in my models, what I've noticed is Quen works better. Llama 3.1 works better if you pass the context as a part of the user prompt rather than the system prompt. And because of Pydantic, the only way to do this is by having a leaky abstraction, which is so annoying. I think they have some kind of an issue to allow you to modify the user prompt, but hey, you know what? It is what it is. Cool. Let's proceed. Then we get the extracted result. The extracted result is nothing but the summarized result. So the extractor, like I said, it's going to go through the entire context and is going to summarize the actual response for me. And then I take that final answer and shove it in an array. So for every sub-question, we are getting an answer and we're shoving it in the context array. And then the finalizer, again, we prepare a context for the finalizer and we just tell the finalizer that, hey, answer the original question. So far, we were using the sub-question. But now we're telling the finalizer, hey, answer the original question, but use the aggregated context. So don't try to query the retrieval pipeline anymore. Prepare a context from the various contexts which the extractor gave us, essentially. Does that make sense? Are you guys with me? Give me a 1 in chat if you guys are with me. I'm going to look at the different questions. All instruction models seem to be hallucinating a lot. Oh, okay. So the question is, Sake just asked the question, any tips on choosing a model for the agentic framework? All the instruction models I'm using seem to be hallucinating a lot and they feel like they're way more complex than what is needed. Fair enough. It really depends. I think I answered this question already. Yeah, but in this context, the way you craft your system prompts and the way you give your instructions is very important, because whatever I'm doing right now is using 32 billion parameter models. As a rule of thumb, 8 billion parameter models are only good for English to English transformations. Maybe a little bit of structured responses, but mostly they're just good for English to English transformations. Llama 3.1, sure, use it for summarizing, use it for extrapolating, and use it for things like that. The moment you get into the reasoning territory, 8 billion parameter models are going to start to struggle there. 32 billion parameter models, on the other hand, have some capability of reasoning. They can do a little bit of reasoning, okay? They can do a little bit of reasoning. Again, if you try to create instructions which are multiple steps, you'll have to decompose that. So you'll have to use like a 32 billion parameter model to decompose a complex instruction into sub-instructions and then orchestrate that, like what I'm doing here, to give each model a simpler instruction instead. So you'll have to use some kind of decomposition there. But if decomposition or that orchestration of combining results back after decomposition, if that's complicated for you, just use a bigger model. There's no other way around it. Have you done anything complex enough to use agent communication messaging system yet? I'm not sure what we mean by that. I mean, we are doing agent communication in a way here. Technically, we are taking the output of one agent and giving it to the next agent. All of this is short-term memory. Technically, some people might even call it long-term memory because it's not, because their definition of memory differs for different people. But the point is, you are taking the output of one agent and giving it to another agent. So I'm not sure if that qualifies as agentic communication beyond. So you might want to drill down a little bit more. But the second part of your question is messaging system. So, yes, I have had the requirement of using messaging systems okay. What I think Beyond is talking about is, do you need like a messaging bus in the middle to talk to different agents? Technically, you don't need that for the agentic system. You need that for workflow orchestration. So if your workflow orchestration requires human inputs or has pauses, basically it's a long running workflow, you might want to start using like workflow orchestration, which is using messaging systems under the hood, right? You're getting into event source architectures and things like that. But again, that's a property not of the agentic system, but of your workflow. Your workflow kind of needs those pauses or communication between different kind of services and things like that, right? Because you need human input, or maybe you're talking to different services or things like that. Again, outside the scope of agentic systems. But I'm not sure if I understood your question right. So I hope I did, and I hope this is the better answer. And we just got a 0.75 as an answer. Oh my God, something is not clear. I'm really sorry if I wasn't able to explain things in more detail. But the idea is that we are creating a workflow using simple Python, right? So like we're using the planner agent to create a list of sub-questions. Then we loop over the sub-questions. Then for each sub-question, we get the context using an agent, and then we summarize the context using another agent. Then we shove it into a master context list. So this context list will not contain the raw context, the raw chunks. It will contain the summarized results from the agents, right? So it's short, it's crisp, and it's just gonna have the relevant pieces of information, which makes the job for our finalizer easy. So the finalizer just is using the crisp summaries and using that as the context, and then it's finally just running it. That's pretty much it. One drawback you will see here is that I'm running all of these retrievers in series, like sequentially, one after the other. Technically, yes, you could run this as separate coroutines by using async IO, but that's a lot of hard work, right? That's a lot of hard work. LangGraph gives you a much better way to loop over things and do things in parallel. LangGraph is a much better framework. LangGraph is a much better framework for any form of orchestration. So, like I said, looping over things and then calling these two agents for each loop can be done in parallel because these are independent questions. LangGraph just makes that so much easier. The code, yes, I'm going to be pushing this code soon. It's not committed yet. Right after the stream, I'm going to put it. You know what? While we conclude the stream, I'll just commit all of this and push it to Git so that you at least have a tentative link to the final GitHub repo. Right? So it's going to go on Git. Don't worry. You guys are going to get the code. Let's run this. Let's see if it actually works. The moment of truth, guys. Even I've not seen if this works. So we run it. The first step, remember, was decomposing our query into smaller things. So the planner agent comes in and it figure out some questions. So what normal type attacks does Pikachu have? What is the power of Pikachu's normal type attack? What is the highest level at which Pikachu can learn a normal type attack? Okay, this is not a good question, but it's fine. So it came up with 6 questions, sets of 3 questions for each Pokemon we had. So if we had 3 Pokemons, I think it would have gone for 9 questions. That's fine. We can optimize the system prompt to make this a little bit better. I don't think it really matters a lot. So I think we're starting to get the answer. So we're going in the loop. So we're going for the first question. What normal type attacks does Pikachu have? So we got the answer. We've got body slam, we've got counter, defense curl, double edge, endure, blah, 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 whatever. We've got a lot of attacks. Maybe not all of them are normal type. Maybe it's screwed it up a little bit. It's possible. It's fine. We don't really care about the quality of the summarization here. We're looking at the process, right? Because I said it's really scuffed. Maybe it might not even work, but let's see. The next question was, what is the power level of Pikachu's normal type attacks, right? It did that too. Wow. So the second question, we got the answer for that too. Quick attack is 40, slam is 80. Good job. Good job. By the way, summarization is happening using an 8 billion parameter model, if I'm not wrong. It's using an 8 billion parameter model. We're doing this with 8 billion parameter model, guys. What the hell? What the hell? And then the next question was, where's the next question? Yeah. What is the highest level at which Pikachu can learn a normal type attack? This is a stupid question, but sure. I mean, it's a stupid question with some stupid answers. It's fine. Sometimes you get some stupid answers. There's nothing you can do about it. And then finally, you have Charizard. I think the same thing is happening for Charizard, right? We're listing all the normal type attacks. We also got like its power levels, like the power levels for each normal type attack. Great. Where's the final answer? Yeah, here we go. The final answer. So to answer the user's question, blah, 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 Pikachu's attacks are Body Slam, which is 85, Double Edge, which is 120, blah, blah, blah. Okay, cool. So Mega Kick seems to be the most powerful attack which Pikachu has, which is 120. And then for Charizard, it seems to be Mega Kick as well. Okay, both can do Mega Kick or Double Edge. So they both have the same attack. Let's confirm this. Is it true? Is this accurate? Does Pikachu learn Mega Kick? Oh, where did it get Mega Kick? Pikachu doesn't. Charizard doesn't learn Mega Kick. I think it's. I was gonna say something I'm not supposed to say on stream. I think it messed up. Okay, I think it messed up. Which is fine. I think we can run it a couple of times again and maybe we get a better answer. Does Pikachu learn Mega Kick? Pikachu doesn't learn Mega Kick as well? Where did it get Mega Kick from? I mean, nobody even mentions Mega Kick anywhere. Oh. It's mentioned here. Hold on. Crazy. I don't know where did it get that answer from. Mega Kick is not even on the page. That is freaky. Let's try to run it again. Maybe make the planner a little bit better. Actually, I don't know how to make the planner a little bit better. You need to break the user's question into smaller groups of questions. Yep. You know, I'm gonna cheat. I'm gonna cheat here, okay? I'm gonna cheat. Just don't tell anybody. We won't put this in the final cut of YouTube, okay? Remove this from the final cut of YouTube. Power and the moves can be asked in a single question. So I'm actually giving it a hint that, hey, you know, you can cup power and moves into a single question. Don't tell anybody that. Don't tell anybody we're cheating. But I really want to see if it can get it right. Or maybe I was thinking of Langroid. What? I've not heard of that. Maybe I was thinking of Langroid, but basically allowing agents to collaborate and coordinate and synthesize new actions. Oh, okay. So you're basically talking about agents which can maybe create new agents or maybe create tools on the fly. I think AutoGen can do that as well. Sure, you can do that. I've never had a use case to do that because the moment you start getting into the territory of letting agents do a lot more work, like deciding the entire workflow by itself, or deciding or writing code for the tools itself, you lose control. You lose control as a developer, which might not be the best strategy. Again, if you're using really, really powerful models, maybe it's going to work. But yeah, beyond, you just mentioned it yourself. It can go off the rails. So I subscribe to the mindset. This is an opinion. I subscribe to a mindset where I think the current state of AI requires a partnership between the developer who architects AI solution and models who can handle indeterminism. It's a partnership. You need to know what is going to be in your control and you need to know where do you want to relinquish control. Like in my example, what we saw here, if you open Excalibur again, we are keeping control of the workflow. We are explicitly saying that, hey, planner is going to give us a list of questions. We are going to iterate over it, get a summary, and then, finally combine the summary into an array of context. That's my decision. And then formulate the final context for deduction. I, as a developer, have made those calls. I'm not letting AI decide that. Maybe I use ChatGPT to figure this flow out. Maybe. That's something you will never know. I can use AI as a developer to write my code, which is fine, right? But at the end of the day, I made the decision this is how the workflow is going to be. However, identifying or decomposing questions into smaller questions, that's an indeterministic task. I don't know how to do it. So I'm going to relinquish control for doing that to an agent. So I'm really controlling what an agent can do and what cannot do, and what role is it playing in my larger workflow. That's my take. That is my take. And that is why LangGraph is my favorite tool, is my favorite agentic framework. That is, it has the precise balance between what the user needs to control or what the developer needs to control and what an agent controls. It's really good. It's a little verbose, but it's really good. Again, we'll talk about LangGraph in the stream coming up in January, okay? So we'll do LangGraph next year. But okay, let's look at the answer this time. Pikachu has a more powerful normal type attack Slam, which has 80 points. And Charizard has Slash, which is 70 points. Okay, I think this is a lot better. Wait, what was the question it came up with? Yeah, it just came up with 2 questions. What is the power of Pikachu's strongest normal type attack? And what is the power of Charizard's normal type attack? I think these are good questions. And then for the first guy, it said that, okay, for Pikachu, it's gonna say, what is the power of Okay, whatever. No, hold on. Okay, this is what went to the agent. Oh, I did not log the rewritten query. But yeah, that's fine. I think the rewritten query would be very concise anyways. That's fine. It doesn't matter. But this is the final answer. Pikachu wins because it has Slam. Let's compare it. Does Pikachu have Slam? I think it does have Slam. Pikachu does have Slam. Slam, it's 80. Perfect. That's right. And that is the best normal type attack move Pikachu has. Charizard, on the other hand, it doesn't have Slash. Where did it get Slash from? Oh wait, it got Slash from here. My bad. Yup. Slash is the best normal type attack. Sweet. Fair enough. We got the right answer, guys. Our humble little open source models have finally given us the right answer. Sure, we did a little bit, we did cheat a little bit, okay? We made the query planner. Technically, it's not cheating. We just said that, hey, you know what? If you want to compare power type moves and things like that, you can combine them into a single question. That's all we did. We did not even give it the questions, okay? We just suggested that you could combine some questions. So even if it's cheating, I think it's cheating of a true gentleman. So that's cheating, which is allowed in my books, okay? But after that, all of this, it figured out by itself, which is amazing. I just want to try one last question because I think Alka had a question on those lines. What just happened? What just happened? Okay. My computer just flickered. For some reason. This is scary. Am I still alive, guys? Give me a 1 in chat if I'm still alive. Give me a 1 in chat if you can still see my screen. Okay. Oh my god, I don't know, something happened and all the screens just went blank and it came up again. Okay, I think it's back to normal now. That was scary. That was so scary. Happens sometimes. Sweet. So let's just do one last question, which, Alka had. What if, because right now we're still working with models, or we're still working with questions which are very fine-tuned towards a single Pokemon. Because that's how we made the retriever agent, right? We made it very specific to a single set of Pokemon. So let's change that. we are going to make it a little bit more dynamic. So I'm going to remove this Pokemon crap. I'm going to remove Pokemon from here. Yep, you go away. We don't need ya. I'm going to remove this as well. Sweet. The same thing comes here. You need to go away. You need to go away as well. And then you need to go away as well. Cool. Sounds good. So now this is very generic, okay? Now we're getting into like extremely generic territory where we are not doing that hack with Pokemon or things like that. Oh, I forgot to remove this guy. Ah. Why is it not working? Okay, now it worked. Yep. Sweet. So what was I talking about? Yeah, we're gonna change the query, and we're gonna change the query to I don't know, something which could be common across Pokemons, right? Which Pokemons learn the move Thunderbolt and Growl? Okay, so we are asking it a question which is which Pokemons learn the move Thunderbolt and Growl. So this would require scans across. This is going to require scans across different Pokemons. Okay, I'm scared. I have a feeling it's probably not going to work. But I'm going to make one more change, and the change is I want to print out the rewritten query, because somebody had a question regarding does rewriting help or not. So we can test that out, but at least I want to show you what the rewritten query was. I can do that at least, right? So let's run this. Did I save it? Did I save this? 03. Which Pokemons learn the move Thunderbolt and Growl? So Thunderbolt should be Raichu and Pikachu, and Growl should be again Pikachu, Raichu, Slowpoke, and maybe Charizard learns Growl. I'm not sure. Charmander learns Growl, so I think Charizard would learn it as well. Cool. Let's run this. Oh my god, I'm scared. I am scared for this one. But again, whose question was that? Sanket? My highest model parameter count in this is 32 billion. So whatever you see happen on screen, all of this is 32 billion parameter model as a top, as a max. So even if you're getting somewhat similar answers, somewhat non-hallucinated answers, we're doing it through open source models. So what I'm trying to say is it's possible, guys. It's possible. If you make a good workflow and you break it down and you decompose the workflow into smaller steps, you should get good results even with open models. So identified sub-questions. Okay, what are the questions? Do you want to know about what? I just appreciate open source models, and this is the question it gives me back. What the hell? Okay, list of Pokemons that can learn Thunderbolt and list of Pokemons that can learn Growl. What? I think these two questions are still fine if we rewrite the queries in a right way, but let's have a look at it. Let's say what it's doing. You're going to see the magic of rewriting right now, Beyond. You're going to see the magic of rewriting. So the first question. Pokemon which can do Thunderbolt and Growl. See what it was rewritten to. Thunderbolt and Growl. That's a good rewrite for a keyword search. That's a very good rewrite. Because we just need to look for the words of Thunderbolt and Growl in our prompt, right? That's pretty much all we need to do. But again, since it's doing Thunderbolt and Growl both together, the chunk quality is not going to be great. So it just came up with Pikachu. It just came up with one good chunk. That's fine. Let's see what comes next. Thunderbolt. The rewritten query was just Thunderbolt. That's a good query again. Yep. We got both the answers. Pikachu and Raichu both learned Thunderbolt. That's the right answer. That is the right answer. Then the next question, just Growl. Very good. Only Slowpoke came in. Slowpoke. Oh my god, I can't even pronounce this creature. Only Slowpoke came in. So Again, there could be more answers here, but it did not give us all the answers. So Thunderbolt. But these are not Pokemons, buddy. Open source models have just let me down here. For some reason, it thinks Ruby and Sapphire are different Pokemons. They're not Pokemons. You need to name the wait, what's my query? Name the Pokemons that learn the move Growl or... Okay, I hope I get a better one this time. And there's one more thing. The retriever, we have to increase the number of chunks that we are retrieving. Actually, let's make it a little bit bigger. I'm not sure if this will work, but let's get more chunks, because if you're trying to like read multiple, you're trying to like get multiple chunks in the response, you'll have to increase the top K, right? My top K was just 3, which is 2 less. So let's run this again. I just hope I don't run out of context memory. Don't blame the model, blame the prompt. Or blame the top K. Blame the top K. The top K wasn't good. We had just 3 top K, which is not good. Okay, so these are 2 good questions. Which Pokemon can learn Thunderbolt, which can learn Growl? Good questions, fair enough. Then the first search was just for the word Thunderbolt. We got Pikachu and Raichu as the answer. That's good. That's really good. These are the 2 Pokemons we care about. Then we go for the next question, which is which Pokemons can learn the move Growl. It rewrote it to just Growl. So keyword search on just the word Growl is definitely going to give you good answers. And there you go. We're getting better answers already. We got Slowpoke, we got Pikachu, and we got Charizard. That's good. Not exhaustive, but good. I think if we would have increased the top K furthermore, we would have gotten better answers. I think, but I'm running out of context size, so I'm going to keep the top K to 7. Or increasing the top K to 20, but having a re-ranker, I think that would be even better. But okay, the final answer, the Pokemons that can learn Thunderbolt are Raichu and Pikachu, and the Pokemons which can learn Growl are Slowpoke, Pikachu, and Charizard. The only thing it missed was that Raichu can learn Growl as well. That's pretty good. But again, for such queries, I think graphs would be a better solution, because through graphs, I could just say that, hey, I need to find the node which says Growl, and I need to see all the Pokemons which are connected to that node. So graphs are the best way to traverse information. This is a question which requires traversal. So we will be having a stream on GraphRack soon. Again, Prashant, dude, I've got a lot of streams which are dependent on you, my friend. Otherwise, I'm going to do it myself. So do you want me to do it myself? Probably not, right? So make sure you come on my stream soon. But not too shabby, man. Not too shabby. Just changing the top key a little bit gave me a much better answer. Open source models for the win again. I'm just getting myself into LLM and related topics and love your walkthroughs. Could you please review Llama Index and share your thoughts? It's not clear where it fits in the ecosystem. Sure. Yeah, we could have, we could definitely have streams on Llama Index and things like that. The point is, my retrieval pipelines, so this utility function which I built, this one, perform FTS search, perform vector search. This is technically Llama Index helps you with. This is something it gives you libraries for. Now, this is a very naive retrieval strategy. It's very naive. It doesn't do anything fancy. Llama Index has more better or slightly more powerful retrieval strategies, but that's what pretty much it does, right? It's more powerful. That's pretty much it, guys. I think that's pretty much all I had for you guys. Thanks for, oops. We didn't notice that. We did not notice that bottle in there. But yeah, thanks for, taking your time out and joining the stream. I know this was such a scuff stream. Oh my God, such a scuff stream. I should have done a better job. Last minute preparation kind of threw me off a little. I'm really sorry for that. I think I could have made it even better. But beyond, glad you liked it. Glad you liked the stream. Do join my Discord. I'm going to drop a link to my Discord right here in the chat. Where is Discord? Yep, there you go. So I'm going to drop a link to the Discord right in the chat. And one more thing, guys. Do join the Discord server. Why? I am going to be, so a lot of, like, I don't come from the AI world, right? And I had to spend a lot of time and energy to learn these things. And I'm learning things with you, right? A lot of things. I'm just learning things. With you. But it's hard to be self-motivated to learn things. So what I've understood that in AI, especially in this generative AI space, there are a lot of resources to learn things. But what we need is initiative, right? You don't need videos on to teach you things. There are already a lot of videos, and you can do all of those things. What we need is companionship and accountability to make sure we take action. We need to take initiative. And I think I need help with this as well. And next month, maybe maybe not next month, but early next year, definitely early next year, I am cooking up something. So do join my Discord, keep an eye out. And I want to create a program where we can hold each other accountable and make sure we keep learning together, right? I'm still crafting this. I'm still trying to figure out how it's going to work. So do join my Discord server. There's a lot of things that I'm cooking up, especially on how we can start learning AI collectively and start taking action and start making some progress towards this AI journey, right? And keep ourselves accountable. So do join my Discord server. I've dropped a link in the chat. Thank you so much, Kalyan. I'm glad you appreciated it. Thanks, Beyond. Glad you liked it. You guys helped me make these streams so awesome, man. I mean, it's all because of you guys. I mean, I don't think I would have be able to make this content without the questions you guys put in chat. I literally go through all the questions you have, all the questions you send me one-on-one, even the questions that you send on Discord, like some of y'all do. I go through them and I make sure that I make it part of my streams. And this 2-hour streams gives me enough time to even go deeper into subjects, right? So you are the people who make these streams such an amazing place to be. So thank you so much. Thank you so much for participating. Thank you so much for motivating me. And thank you so much for helping me improve the quality of the content here, guys. I really appreciate it. Alka says, it was amazing. One of your top K3. That's a nice pun. Thank you so much, Alka. I appreciate that. All right, guys. I think that's pretty much it. Do join my Discord. Like I said, like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud, guys. Here on YouTube and hopefully in real life. See ya. How do you end the stream? Oh, shit. Wait, did I lose the stream? Oh, I can end it. I can end it now.